welcome back. In this video lecture, we will start the projection of point and projection of line. Okay, so before starting the projection of line and point, these are the notations that you have to use while you're drawing the projection. As I have told you, like you don't have to write the front view, top view, and front side view. You only have to draw the drawing. Then how I will get to know that where you're drawing the top view, side view, and front view. Okay, so these are the notations. Like for the top view, okay, there is a point A. Then you have to, in the top view, you have to indicate it like a small a. While you are drawing the front view, okay, then you have to indicate it with the help of a dash, and in the side view, a double dash. Similarly, if there is a line like AB, then in the top view, what will you have to write is the a small a and small b. In the front view, a dash b dash, and in the side view, a double dash b double dash. The similar way, if they are numbers, then you have to write like 1. Here you have to write the 1 2. It is 1 dash 2 dash 1 double dash 1. Here 1 double dash 2 double dash. Okay, so starting with the point. So suppose your point A is in the first quadrant, and there the situation like point A is above the HP and in front of VP. Okay, so the distance will be given. So it is your vertical plane and horizontal plane. Your point is above the HP, means this is your horizontal plane, so point will be somewhere here and in front of VP. Okay, this is your XY line and this is your point. So drawing the front view and top view like this. So in 3D you can see this is your A dash and this is your A. In the similar way, there is another example like point A is above the HP and in the VP. Okay, so above the HP means your point will be somewhere here, and in the VP means this is your vertical plane. Means this time your point is nothing but in the vertical plane. Like this, front view of this point will be this one only, and this is your top view. Okay, this is your top view and this is your front view. The similar way, there is another example like point A is in the HP and in front of VP. Okay, so here you have to, so this is the way you have to draw in the drawing sheet. Okay, this is your vertical plane and this is your horizontal plane. So always remember that your vertical plane will be standing like this only, it will not move. Then you have to always move the horizontal plane and profile plane. Whenever you are rotating the horizontal plane, remember that the horizontal plane always move in the clockwise direction. So here, if it is moving in the clockwise direction, then the horizontal plane will be at the bottom of the vertical plane. This rectangle box you don't have to draw, as I mentioned earlier. You have to only draw the reference line, this point A dash and A, and this projector line joining the A dash and A. Here you can see these are the projectors, and here are the projection of the projectors on the vertical plane and horizontal plane. So basically you are drawing the position of the projectors. Okay, these lines you are drawing here. The similar way you can see here with the answer of this question, like A dash will be in the vertical plane only, top view will be on the reference line. Okay, the same way you can draw the projection of this point A. Okay, so this will be your point A in the top view, and in the front view, if you see, it will project on the reference line. So this is your front view, and your front view is on the line XY. So as I mentioned earlier, showing here, this is your vertical plane and this is your horizontal plane. So if you are drawing the projection of any point A, then you have to move the horizontal plane in the clockwise direction like this. So suppose now your object is on the second quadrant. This will be your front view and this will be your top view. So vertical plane will be here only, and horizontal plane you have to move it in the clockwise direction. So if you move it in the clockwise direction, then your horizontal plane and vertical plane will coincide. So here you can see this is your front view and this is your top view. Both are the above the XY line or reference line. The same way you can see if your point is on the third quadrant, so now your horizontal plane will be at the top of the vertical plane. And here you can see this, if your point is in the fourth quadrant, then your horizontal plane you have to move downward in the clockwise direction. Then again your horizontal plane and vertical plane lie, or you can say coincide. Okay, so both will be on the below the reference line. Some example problems on projection of points. So here are the first example. A point A is 20 mm above the HP and 30 mm in front of VP. Draw its projection. Okay, so if the point is 20 mm above the HP, means it can be either in the first quadrant or second quadrant. Now it is given that your point is 30 mm in front of VP, means your point is in the first quadrant. Okay, so when you draw the projection of this point, first you will draw the line XY. This is your reference line with the help of HB pencil. After that, if your point is in 20 mm above the HP, okay, so this distance you can see when you are doing the front view of this point. Okay, so like this, if it is 20 mm, this will be your projection of a point A, front view of a projection of a point A, and I will indicate it like A dash because it is the front view. Now again, it is 30 mm in front of VP, so we can see this distance when we are looking at the top. Okay, means when you are drawing the top view, the point will be you can see the 30 mm distance, because this is top view. I will indicate the point A as the small a. Okay, and this is your projector. So these are the dimensions line and this is your extension line. So this line you have to draw with the help of 2H pencil. This projector line you have to draw with the help of a 2H pencil. Okay, this point and this A dash, 20 mm and 30 mm, you have to write with the help of HB pencil. Now it is another example. Now your point A is 20 mm below the HP, means it can be either in the third quadrant or fourth quadrant, and 30 mm behind the VP, means your point is now in the third quadrant. Okay, so again when we are drawing the projection, this 20 mm distance you can see when you are drawing the front view of the point, and 30 mm you can see when you are drawing the top view of the point. Okay, so the only difference will be your now front view will be at the bottom and the top view will be at the above the reference line. So this is how you can mark the top view of the point, and this is your front view of the point. Okay, now we will see the position of the lines. Whenever you are drawing the projection of the line, this kind of information will be given in the question, like end position of the line, its length, its inclination with the horizontal plane or vertical plane. Okay, it can be either a inclination with the horizontal plane or vertical plane, or can be both. Okay, and if it is asked to draw the projection of the point, projection of the line, means you have to draw the front view and top view. And if asked, you have to draw also the side view of the any line. Okay, here is some simple cases, like a vertical line is given, and here it is perpendicular to the HP and parallel to the VP. The another example, like line parallel to the both HP and VP, line inclined to the HP and parallel to the VP, line inclined to the VP and parallel to the HP, and the line inclined to the each and every case in the next few slides. Okay, so starting with the line is vertical. So if your line is perpendicular to the HP and parallel to the VP, okay, so suppose the end position of the line is given you. So if the end position is given, you can easily draw the line like this. Suppose it is 20 mm and the end position of other end of the line is suppose is 70 mm away from the HP, or it can be given as the position of the one end and length of the line. Okay, so suppose the length of the line is 50 mm and this point is 20 mm above from the HP. Okay, now I want to draw the position of this line. So simply it will be a straight line when I draw the front view. When I look at from the top, then I will get the position of this line as the point, and the distance from the vertical plane is also given to you. Suppose it is 30 mm. Okay, so this is your front view, this is your top view, and okay, so this is your point A. So it is the front view, means A dash. It is a point B. In the front view, you will indicate it as the B dash. If it seeing from the top, then the both point A and B is at the same position, and this is a projected. This is the second case when the line A is parallel to the HP and parallel to the VP both, means the line will be like this, and the distance of the line from the vertical plane you can take as the 30 mm or 30 mm, and you have to draw the projection of this line. Then of course if it is a parallel to the VP and parallel to the HP, means in the both plane you will get the straight line, and the length of the line will be the same as the length of the line given in the question. Like if it is a 50 mm, you will get the projection line, and the length of this line will be nothing but the 50 mm. And in the top view also, the length of projected line will be nothing but the 50 mm. The point to be noted, like if the line is parallel to the any plane, and if you project the line in that plane, then you will get the true length. True length is nothing but the original length of the line. Okay, so this is how you can draw the projection of the line in your drawing sheet. Okay, so this distance is nothing but the 20 mm, and the length of the line is 50 mm. You can mark those lengths, and this is the 30 mm distance, and this is the solution of this particular question. The same way, if a line is inclined to the HP and parallel to the VP, so you can take the inclination of a line as the 30 degree. So this is your line, and okay, and this inclination is 30 degree from the HP. The end position of this point you can take as the 20 mm, and the length of the line you can take as the 50 mm. So the end position of this point you will get automatically with the line at the 30 degree angle. Okay, so when I draw the front view, I will get the line, the same line in the front view in the vertical plane. Okay, and this is your point A dash, this is your point B dash. And when you draw the projection in the horizontal plane as the top view, then the length will get reduced, right? Because talk in a term of mathematics, this length will be nothing but the AB cos of theta, right? Means 50 cos of 30 degree. Okay, so this is how you can draw the projection of the line in the drawing sheet. And whenever you are drawing the projection of the line, first you have to draw the front view. Okay, and this position of the point is 20 mm. Then you can draw this line at the 30 degree angle, and the length of this line is 50 mm. Okay, so you will get the front view of the line AB. After that, what you can do is you can draw the projectors. Okay, you don't have to measure this length, because this A point will be on the same projectors, and this B dash and B will be on the same projectors. So I will draw the projector, okay, from the both of the points, and the distance of the point from the vertical plane, suppose it is given as the 30 mm, then this distance will be nothing but the 30 mm. Okay, so this is how you will get the top view of the line AB. The same way, if it is given that the line is inclined to the VP and parallel to the HP, again you can take the inclination as 30 degree, okay, and distance from the HP, because it is parallel to the HP, the distance from the HP you can take as the 30 mm, and the position of a point A of line AB from the vertical plane you can take as the 20 mm. Okay, so this distance is 20 mm from the vertical plane, this length is 50 mm, and the inclination you can take as the 30 degree. So this is how you will get the top view and front view of the line AB, and this is your final answer. Okay, so in this both pictures you can see this line AB dash, A dash, B dash and AB you have to draw with the help of a HB pencil. This projectors lines A dash A and B dash B you have to draw with the help of 2H pencil. The reference line you can draw with the help of HB pencil. Okay, you don't have to write front view and top view. You don't have to draw this rectangle or square. Okay, and only thing you have to write is the XY, A dash, B dash, angle, the length of the line which is given in the question, the position of the points if given in the question. Okay, so now if your line is inclined to the both HP and VP, so suppose this is your line AB, you can take the inclination of the line from the HP as a 30 degree and from VP as the 45 degree. Okay, and the length of the line you can take as the 50 mm. The position of the point, at least you position of a point A from the HP and VP, so you can mark the position point A. So this is how you will get the front view and top view. See here, if it is 30 degree and you're drawing the front view, this angle alpha will be more than 30 degree. The same way, if the inclination of line AB from the vertical plane is 45 degree, so whenever you are drawing the top view, then the beta angle will be more than 45 degree, and the length of these two both projection line will be less than the length of the line AB. Okay, because this line is inclined to the both of the plane, and we have seen in the previous diagram. In this picture, whenever the line is inclined to any plane and you draw the projection on that plane, like in this case it is inclined to the horizontal plane and we are drawing the projection on the horizontal plane, means it is a top view, then this length is less than the length of the AB, right? So the same way here we can see, if here your line is inclined to the both VP and HP, so whenever we are drawing the projection on the HP and VP, we will not get the true length of the line AB. It will be a less than the length of the line AB. So after getting the projection, we will see in the next slide how we will draw the projection of line AB if this kind of situation is given to you. Getting the projection, okay, this is your final answer. So before that, we will see the angle that I have told you. This angle will be more than the angle given in the question. So in this video, you will see how it is come out to be more than the angle given in the question. Okay, so suppose this is your line AB, okay, and this is your vertical distance of a point B from the reference line, and this is your point A. Okay, and I am moving the point, moving the line from with reference to point A, vertical plane also. You can consider this as the vertical plane, okay, and when I am rotating the line, you are getting the inclination with the vertical plane also. Okay, so this is how you can see, if you are rotating the line with respect to this point, then this point B, the distance of a point B from the horizontal line, this horizontal line will remain same, right? If it is suppose it is 20 mm from this green line, then the projection of the point will be on this horizontal line. Okay, it is when I rotate this line is now at this position. This distance is again 20 mm only, okay, but now this point is moved out to be at this position. When I draw the projection, then the point will fall somewhere here, and when I join this point with the origin, then you can see the angle is now more than the previous angle. That's concept. Okay, we will draw the projection of the line. Okay, so for that, what I will do is first I will draw the projection of the line. Suppose your line is only inclined to the horizontal plane, then this angle will be 30 degree, and this is your point A dash, and this is your B1 dash. I am taking it as a B1 dash because it is not the final position of the point B. Whenever I get the final position of the point B, then I will indicate that point as the B dash. Okay. The similar way I can draw the position of the line when it is only inclined to the vertical plane. This angle is nothing but the 45 degree of phi. Okay. So when the line is inclined to the vertical plane at 45 degree, then I have to draw the front view of that point. This is your top view. I have to draw the front view of that line. Okay. So this is how I can draw the front view of that line when it is only inclined to the vertical plane. So this point I am indicating as the B1. So you can take it as the B2. Okay. So this is how we are getting the length of the projected line. Okay. When this is 45 degree, then this length will be nothing but the 50 mm. If you are taking the length of the line as a 50 mm, then this line will be 50 mm into cos of 45 degree. So this is how we are getting the length of the projected line. And as in the previous diagram we have seen, your point will be on this horizontal line when we are rotating this line with respect to point A dash, right? And we know the length of the line. So what I will do is I will take the rounder. I will mark the length of A dash, and this is a point B2. I will mark the distance A dash B2 on the rounder, and I will cut an arc on this horizontal line. So this is the final position of the point B in the front view, and I will indicate it as the B dash. Okay, this is your final front view, and for getting the top view of the point B dash, either I can draw the projector that will cut on this horizontal line, because as I told you, the points will be on the same projectors. Like it is A dash A, it is on the same projector. Like in the same way, your point B dash and B will be on the same projector. So either I can draw the projector like this, or I will repeat the procedure as I done to get the point B dash like this. So for that I will draw the top view of line A dash B1 dash like this. Okay, so I will get the length of the top view, and I know the point B will be on this line. So I will take the rounder, mark the distance A B2 dash, sorry B2, A B2, and I will cut an arc here. So this is how I will get the top view of the point. Okay, and here you can see the angle is now more than theta. This angle is more than theta, and this angle is more than phi. The same way, suppose the projection of the line is given to you, and you have to find out the true length of the line. Okay, so I will follow the reverse process. Means the projection is given to you, means the projected length is given to you, the position of the point is given to you. Okay, so I will uh, rotate this line and make it parallel to the line XY. See, so basically what are you doing here is you are making the line parallel to the XY line. Means now this line is parallel to the vertical plane. Okay, if it is parallel to the vertical plane, and I have mentioned earlier, if any line is parallel to any plane, in that plane we will see the true length of that line and true angle of that line. Means in the front view, in the vertical plane we will see the front view. We are making the line parallel to the vertical plane. Okay, and in the vertical plane we see the front view of that line. Means in the front view we are going to get the true length and true angle of that line. Okay, so if the line is parallel to the xy line, and I will project this line to this horizontal line, then I will get the projection of a line when it is inclined to the only horizontal plane. And from that you can mark the true length of this line. Okay, and also you can also find out the true angle if it is asked in the question. The same way you can also find out the true angle from the vertical plane also. See, in the whole diagrams, the one thing I want to mention that the notations here that were used is not proper. See, uh, in this picture, if you can see, it is your point B1 dash. Okay, and this is your point 1 dash. Then you should indicate this point either as a 1 or B1. Okay, if you are using that, then this point you should indicate. So if you are doing that, then this point you should indicate like B2, and this should be 2, and this point will be nothing but the B2 dash or 2 dash. Okay, then it will be a proper indication of the points. The similar way you can see here, if it is your point B2, then this would be B2 dash. Okay. Okay, this is your example problem. If it is given that the line AB 75 mm long and it is 30 degree and 40 degree inclined to the HP and VP respectively. The end A is 12 mm above the HP and 10 mm in front of VP. Means your point A is in the first quadrant. Draw the projection, and it is also given that as the line is in the first quadrant. Means your point B is also in the first quadrant. Okay, so first I will draw the position of a point A from the reference line. So this distance will be 12 mm and this distance will be 10 mm. Okay, then I will draw the projection of a line AB, considering that the line is only inclined to the horizontal plane. So this is your projection of the line, and this length is 75 mm. This is your, and you will get the point B1 dash. This angle is 30 degree. Then the same way I can draw the top view, considering the line is only inclined to the vertical plane, and this angle will be 40 degree, and this length will be 75 mm. After that I will draw the horizontal line from B1 dash and B1. Then I am drawing the front view of line AB when the line is only inclined to the vertical plane. Then I will get the length of the front view, and I will mark that length on this horizontal line to get the final position of the point B on the front view. and this is how you will get the top view of the point B. Okay. This is your another problem. The line AB 75 mm long, making 45-degree inclination with VP while its front view. Okay. The true inclination of a line is given from the VP as a 45-degree and the front view of the line. Now it is this inclination is front view of a line AB was given. The end A is 10 mm over the HP and 50 mm in front of VP. The position of a point A is given to you. If the line is in the first quadrant, draw its projection and find its inclination with the HP. Okay, so first we have to mark the position of the point A and point B that is given in the question. This distance is 10 mm, this distance is 15 mm. After that, I will draw the inclination of a line from the VP as the 45-degree, right? And the length of the line is given to you, that is 75 mm. Then I will draw the top view of that line, front view of that line. Okay, and I will cut an arc like this, and I will draw the front view of a line that is 55-degree from the horizontal plane. Okay, and this length is not known to you. Okay, so whenever this line is cutting this arc, this is the final position of the point B dash, right? Because it is the angle of front view. So this is your front view only, and whenever this line cut this arc, you will get the final position of point B dash. And after drawing the projector on this horizontal line, you will get the final position of point B in the top view. So in this question, these lines you have to draw with the help of the final position of line. You have to draw with the help of a HB pencil. Okay, and you have to write this A dash, B dash, B1, B, and if it is suppose B1 dash, this is your uh, any point 1. These alphabets you have to write with the help of HB pencil. You don't have to write this locus of point B. You don't have to write this. You don't have to write true length, front view, left, front with these things. Okay, you don't have to write these things. Only you have to mark the points. And these lines you have to draw with the help of a 2H pencil. Only the final position of the line you have to draw with the help of a HB pencil. Okay, projectors you have to draw with the help of a 2H pencil as mentioned earlier also. And after doing that, you have to write the length of the line. Means it is the 55 mm. This angle is 55 degree. You have to mention that. This angle is 45 degree. You have to mention that. This length is 75 mm. This length is 75 mm. True length. You have to mention that length. And also you have to show the position of the line, position of the point A from the reference lines. Okay, it is not shown here. You have to mark the position. Okay, after that it is asked in the question that you have to find the inclination with the HP. Okay, so for that, okay, this is a point V dash we have got, and this is a horizontal line, and this is your point A dash. You have to draw a line of a 75 mm that will cut this horizontal line at some point. Then you will get the inclination of the line from the horizontal plane. So you have to show that inclination also, that is asked in the question. here is the another example. The front view of a line AB is 50-degree inclined to the xy. So again here it is given as the front view of the line AB and measures 55 mm long. So this is the length of the front view of line AB, that is 55 mm, while its top view is 60-degree inclined to the xy line. So this is the top view of a line AB that is making the 60-degree angle. Okay. If end A is 10 mm over the HP and 15 mm in front of VP. So again your point A is in the first quadrant. Draw its projection, find the true length, inclination of a line with HP and VP. So we have to follow in this question the reverse process. Okay, so first we have to mark the position of a point A that is given in the question. Then I will draw a line that is 50 degree from the xy line and having a length of 50 mm. So this is your front view of a line AB, that is A dash B dash. Then I will draw a line at 60 degree, okay, and that will cut this projector, okay, and that is drawn from the B dash. Then I will get the point B. So this is your top view of a line AB, that is small a and small b. Okay, so this is your front view and top view that we have got. Now we have to find the true length and inclination with the HP and VP. For that, I will make the line parallel to the XY line. So by this your line is now parallel to the horizontal plane. So projection in the horizontal plane, that is the top view that will get on the horizontal plane. So your top view we are going to get, that will, so in the top view we are going to get the true length and true inclination of a line AB. From the vertical plane. So here you can measure the angle, what it is making with the vertical plane. The similar way, you can mark the point B here, then on this horizontal line, then you will get the true inclination of a line with the horizontal plane. If you measure this length and this length should be the same, because the line should have only one true length. So by that you can check your solution. So now moving to the traces of the line. So what it is? These are the points of intersection of a line or its extension with respect to the reference plane. Means if your line is inclined to the horizontal plane or vertical plane, and if you extend that line, then wherever it cuts the horizontal plane or vertical plane, that is the traces of the line. So if the line is suppose parallel to the horizontal plane or vertical plane, then it will never cut that plane. Okay, then you will never get the traces of that line. So to get the traces of the line, it is compulsory that the line should be inclined to that plane. So when the line itself or its extension wherever touches the horizontal plane, the trace is called horizontal trace. The similar way, when the line its extension touches the vertical plane, that plane is called vertical trace. So the vertical trace is the point on the vertical plane. So we can see this vertical trace on the front view. The similar way, the horizontal trace is the point of the horizontal plane, means we can see horizontal trace on the top view. So here you can see in the diagram, this is a horizontal plane and this is a vertical plane. This is a reference line. This is a line AB. I am drawing the front view of the line AB as A dash B dash that we have already seen, and this is your vertical. This is your top view, right? So when I extend the line, so it is cutting the horizontal plane at some point. So this is your horizontal trace of the line AB. Okay, so but in the drawing sheet, you're drawing the front view and top view of line AB. So from that, you have to find out the horizontal trace of a line AB. How can you do that? See, if you extend the line A dash B dash, it will cut the reference line at some point. You named that point as the H dash. From the H dash, you have to draw the projector, or you can see the perpendicular line. Okay, and you have to extend the line AB. So whenever that projector and your line AB, that is nothing but the top view of a line AB, cuts at some point, that point is nothing but the horizontal trace. Okay, the similar way you can find out the vertical trace. I am extending the line AB, so it is cutting the vertical plane here, so it is a vertical trace. And in the drawing sheet, how I can find the vertical trace? I will extend the top view up to the reference line, then it will cut the reference line at some point. I will name this point as the V. Then I will draw a perpendicular line, that is nothing but the projector. Then I will extend the front view up to the projector. So whenever the vertical line and this extension of A dash B dash meets at some point, that point is nothing but the vertical trace. So here are the steps that I have just told you. So find out the horizontal trace. These are the steps. Begins with the front view. Extend the front view up to the line XY like this. Then name this point as the H dash. Draw a projector from the H dash, means the vertical line. Now extend the top view to meet the projector. This is your top view. I am extending this line. So wherever they meet is called the horizontal trace. Now to find the vertical trace, we have to extend the line, that is top view. We have to extend the top view up to the XY line, that we have already done. Name this point as the V. Now draw a projector from the V and extend the front view. This is your front view. I will extend the front view. So wherever they meet is the vertical trace. So these are the sub observations, like your point H dash and V always on the XY line, your vertical trace and V on the same projector, your horizontal trace and H dash on the same projector, your front view H dash and VT, your front view H dash and VT. This is on the same line. Your point V, HT and top view on the same line. See, these observations you are going to use in the solving the problems. Okay, so you have to remember these observations. So here are some another important points, like if a line is parallel to any plane, there will be no trace upon that plane, that I have already mentioned. If so, for example, if the line is parallel to the horizontal plane, so you can see this line is parallel to the horizontal plane, so you will get only the vertical trace. The similar way, if the line is parallel to the vertical plane, then there will be no vertical trace, there will be only the horizontal trace. Here are some other examples, like if line is parallel to the horizontal plane, so this is your vertical trace and there will be no horizontal trace. Here another example, like if the line is AB 6 cm long is parallel to the vertical plane and inclined to the horizontal plane at the angle 30 degree. Then draw its projection of the line and find vertical trace and horizontal trace if the point A is 20 mm above the HP and in the VP. So first of all, we have to starting with the marking the point A. So your point A is 20 mm above the HP and in the VP. So if it is in the VP, then the top view will be on the reference line. So this is your A dash, this is your A. Now it is given that your line is parallel to the vertical plane and point A is in the vertical plane. Then the point B should be in the vertical plane as well. So this is your point B. Okay, so if the point B is on the vertical plane, you have to draw the projector from the B dash, then you will get the point B. So this is your top view and this is your front view. So now to get the horizontal trace of a line, I will extend the front view up to the reference line, then I will get the H dash. Then I will draw a projector from the H dash. Then I will extend the line, that is top view, up to the projector. So I will get this point again as the horizontal trace. Okay, so here the H dash and HT both are coincide H at the same point. Now we have to find the vertical trace. So if the line is parallel to the vertical plane, so as per definition there will be no vertical trace. But here your line AB is on the vertical plane, and as per definition, when the line or its extension cuts the vertical plane, that point will be the vertical trace. So here the vertical trace is nothing but the line. So this top view AB is nothing but the vertical trace, the whole line. Now moving to the another example, the front view of a line AB makes 45-degree angle with the XY line and measures 60 mm. So here the front view of a line AB is given. Let's the top view makes 30-degree with XY line. So by that you can find out the front view and top view of a line AB. And A is 15 mm above the HP and its vertical trace is 10 mm below the HP. So here the position of point A is given, that is 15 mm above the HP, and where the other position of a point A, that is below, in front of, or behind the VP is not given. Draw the position of a line AB, determine the inclination with the HP and VP, and locate the horizontal trace and vertical trace. Okay, we will start from the marking the point A. So your point A is 15 mm above the HP. So this is how you can mark the point A. It is A dash. The other position of point A is not given. Okay. Now your VT is 10 mm below the HP. Okay. So, and I know the angle, front view of the angle AB is 45 degree and measurement is 60 mm. So I can draw the front view of a line AB as A dash B dash. And from the property and from the observation, I know that front view H dash and the vertical trace is lie on the same straight line. So I will extend the A dash B dash that will cut in the line XY. Then we will get the H dash and extend it further on this horizontal line. Then we will get the vertical trace. Okay. So now we know the top view of line AB is making 30 degree with the XY line. So I will draw a line from the VT So now what I will do is I will find out the point V, as I know the VT and V lies on the same projector. So I can find out the point V, and from the point V I can draw a straight line at angle of 30 degree. So your top view will lie somewhere here on this line, and I know the position of A dash and B dash, and I know that A dash A and B dash B will lie on the same projector. So I will draw the projector from the A dash and B dash, and I will find out the point A and B. So this is how you can draw the front view and top view of the line AB. After that, it is asked you to find out the inclination of the line with the HP and VP and locate the HT and VT. So for locating the HT, what I will do, I will draw a projector from the H dash, and wherever it cuts on this line will be the HT of the line AB. Then to find out the inclination with the HP and VP, it is the same procedure. Like first we have to make a line parallel to the XY line like this. Then I will join the line, and I know the point B will be lie somewhere here on this horizontal line. Okay, so after drawing the front view of a line, I will project it on this horizontal line and join with the point A dash. This is your true length of line AB, and the true inclination you can measure from here from the HP. The similar way you can find out the true inclination and true length of a line from the vertical plane. So here is another question. One end of a line AB is 10 mm above the HP. The other end of is 100 mm in front of VP. Okay. So if one end you are considering it as A, then it is A is 10 mm above the HP, and the other end means B is 100 mm in front of VP. Its front view is 45 degree inclined to the XY line, while its ST and VT are 40 mm and 30 mm below the XY line. So, and you have to draw the projection and find true length with its inclination with the HP and VP. So first of all, again we will mark the point like A. Okay, this is 10 mm over the HP, and I know the inclination of the and the inclination of a line, front view of a line is 45 degree. Okay, So we don't know the position of a point B. That will we will find out later on. After that, it is given that the horizontal trace and vertical trace are 40 mm, 45 mm and 30 mm below the XY line. So we can draw a horizontal line at 30 mm below the XY line and 45 mm below the XY line. Then I will extend the front view up to the vertical trace line. This your vertical trace line means vertical trace is in 30 mm below the XY line. So this is from when the front view is cutting, when the line that is extended through the front view will cut on this line, you will get the vertical trace. And this is your point H dash. After I can mark the point V by drawing the projector from VT to the XY line. So this is your point V. Okay. Then after that, I know when I draw the projector from the H dash, wherever it cuts this line, it will be HT. Right? Now I know the position of the other point B, that is 100 mm in front of VP. Okay, means top view of a point B is given to you, and when I join this line V and HT, as I know the top view HT and V lies in the same straight line, so I will draw a line joining these 2 points, and I will draw a horizontal line that is 100 mm below the XY line. So wherever this line, straight line that is joining the V and HT cuts that horizontal line, will give you the position of point B. So this is your point B, and if you draw the projector from the A dash, then you will get the position of point A. So this is your A dash, this is your B, A, this is your B, and if you draw the projector, then you will get the B dash. So this is your front view and top view of line AB. Then you have to find the inclination with the HP and VP and true length. So this is the same procedure. You have to first draw a line that will be parallel to the XY line. You can start from the top or bottom. So here you are making the line parallel to the XY line, means your line is now only parallel to the only inclined to the horizontal plane. So this is how you will get the position of a point B when it is only inclined to the horizontal plane. So you can now measure the angle and measure the true length of the line. The similar way you can find out the inclination with the vertical plane, and also you can measure the length, so you can check your uh, procedure is correct or not. That this length and this length should be same. So the position of line and point is completed now, and in the next class we will start the projection of the plane. Thank you very much for your kind attention.